Here's a short little video that gives us a little bit more on arrays. From our previous two videos, you know how to create an array, and how to instantiate the array, and how to loop through the elements of the array with for loops, how to find the number of elements in the array with the dot length attribute. And you might think that arrays are the greatest thing in the world since sliced bread, and they're good at an awful lot of things. Well, let's learn a little bit more about arrays, some things they're good at, and then some things that are really difficult to do with arrays. So we'll set ourselves up for some of the later videos. So let's get going. Now, so far, we've had one-dimensional arrays. Means we've got an array that we keep one index for. We have element 0, element 1, element 2, and so on. Sometimes it's convenient for us to arrange our data into both rows and columns instead of just a row or just a column. For example, we might want to keep track of a student's test scores for 5 different tests. We can do all of this in one variable if we do a two-dimensional array. So let's say I've got a table. I can say int table square brackets again. That says I'm going to have a variable called table that's going to contain a number of elements, each of which is an int. But I'm going to refer to it as a first index and a second index. Then when I do my new statement, table equals new int 25, this gives us an array of size 20, each of whose elements is an array of size 5. So I've got 100 elements overall. How do I refer to it? Just the way you'd think. To refer to a particular row and column, use the row as the first index, the column as the second index. So if I wanted to print out student number 6 had the following score on test number 2, I'd put in table sub 5. Remember, in Java, the index starts with 0, so I get 0, 1, 2, 3, 4, 5. The 6th element is in position 5. And then square bracket 1, that's test number 2, because square bracket 0 would be test number 1, square bracket 1 is test number 2. Okay, that's something arrays can be good at. We can think of a lot of occasions where storing stuff in a two-dimensional table might be useful. So, what are other things arrays are good at? They're useful tools when we want to manipulate a collection of items. They're very convenient when we know how many elements we're going to be using. They make it easy to loop through all of the elements in order. They make it easy for us to refer to a specific element if we know its index. But what are arrays not real good at? Suppose we're going to use an array to store a list of words. Like we're going to read in the text of a chapter of a book. We don't know how many words there are going to be when we start reading it in. But we have to know how big to make our array when we use our new statement. So we have to pick a maximum number and then keep track of how many we actually used. So I might have string square bracket word list equals new string 1,000. Give me 1,000 slots, Java. Now maybe I'm only going to use 800 of them. Maybe I'm only going to use 600 of them. Maybe I'll use all 1,000 of them. But I've got to guess at the beginning 1,000 is the most I would ever need. And then I might keep track of something called num words. How many have I used so far? 0 of them. We have to remember to update num words. Wordlist.length will always have value 1,000 for this array, but I may not have put 1,000 words in there yet. So we have to know the difference between the physical size of the array and what we call the logical size of the array, the part of the array we're really using. Now, another thing, suppose we want to remove elements from an array. Let's say we had an array that had all of these values in it, 4, 7, 11, 8, 7, 3, 6, and 9, and we needed to delete this one. For some reason, that student transferred. We no longer keep that student's information. We want to get it out of our array. Well, we'd want our array now to look like this. 4, 7, 11, 8, 7, 6, 9, where you notice the 6 moved up a slot, and the 9 moved up a slot, and I now have an empty slot, and the 3 is gone. That's hard to do from an array. I can't just get rid of an element in the middle. So how do I do it? I can create a new array and copy just the elements I need into that array. Well, what if I had to do this more than once? Which variable would I use in my programs for the code to know what array to use at any given time if I have to keep copying it to a new one? Or I could do a copy in place, move some of the elements and ignore others. Let's go through an example of that on the next page. So here's that same example, 4, 7, 11, 8, 7. I don't want to keep the 3, a 6, and a 9. So here's the algorithm written in pseudocode, meaning not specific Java syntax, but I could implement this in Java if I wanted. For each element in the array, and I'll use I as an index here, if element I is to be kept, put element I into position J. So I is going to be going down this list of the original array. J is going to be going down this list, the positions that the elements will have after I've deleted the ones that I don't want anymore. So put element I into position J. You have to make sure you didn't forget to initialize J. J is going to start at the top. Then I'm going to increment J. End that if statement and the loop statement. And then remember the total number of elements that I put in the array, which should be equal to J. Now think through that. You may have to do an algorithm like this in Java at some point. Here's a description logically of how it works. But it is a pain. Arrays do not make it convenient to delete elements. There's a better way, but you're going to have to wait until we get to array lists to learn about that better way. Okay, that's it for arrays for now.